Welcome to Going Green podcast. We're going to have a look today at the water cycle. The water cycle is something that many people learn really in the sort of their junior school when they're sort of 8, 9, 10. But the water cycle, well, there's a little bit more to it. And there's a lot here that's important, really, with the things that are affecting us at the moment and climate change. So I'm Philip. This here is Paul.
Hi.
And what we're going to do is we're going to talk about the water cycle. Now, where does the water cycle start, Paul?
Well, usually it starts in the ocean or at the water's surface.
Yeah.
As you might say.
So all of the system here is powered by the sun, and the water is not just heated, because people often think it's sort of water being heated,
And
but
and at boiling temperature.
yeah, but it's water evaporating, and water, and Paul's an expert on this because he's the chemist. Water will evaporate at what temperature to what temperature, Paul?
Well, it depends on what's happening. So if you're talking water surface, then it will evaporate. It depends from 25 all the way up to about 50, depending on the conditions. But that means it is happening all the time when you don't think evaporation. It's not like a kettle boiling and the steam's being given off. No, it's just water vapor. It's just turning from a liquid to a gas without really boiling.
And that happens at a variety of different temperatures. In fact, it actually happens at a much lower temperature than you imagine. But if you've got a bit of sun on some ice, and the ice might be at sort of minus 40, you'll notice that it does disappear. It sublimes, but it's turning there from a solid to a gas. But normally evaporation, we're talking about a liquid from any temperature, from 0 right up to 99 point whatever. And that temperature, water is evaporating rather than necessarily boiling. So our water evaporates and it goes up into the air. Now, if we've got a beautiful blue sky, that normally tells me there's not much water vapor in it.
Yeah, I suppose you're right in that. I'm just having a problem because I'm trying to type as well as you asked me a
Yeah,
question.
the water then is sort of fairly clear, and if we compare perhaps a holiday in the UK and a holiday abroad, the thing that people notice is they say, well, abroad, yeah, where it's warmer, the skies are a lot bluer, whereas in sunny Hemel Hempstead, where we're actually this year still looking to see the sun, I think it's booked for one day in August this year. Even on a blue day,
Yeah.
blue sky is actually not very blue. It's sort of a more grey blue. And today we've got very classic blue sky. It's clouds all the way across. We've got 100% cloud cover here. And I'd like to even include a bit more cloud, because instead of just having that white fluffy stuff, we've got some of that brown, dirty, black sort of stuff. And I mentioned brown because we don't get clean water.
Well, no.
When it rains, I find I go out and have a look at my car, and I have a look at my car, and it's extremely dusty.
Yeah, well, what happens, you see, is where the wind, where is wind created, and that's created on the equator, and it goes either north or south. And fun enough, at the equator, there's this large desert full of sand.
Called
I think it's called the Sahara, isn't it?
the Sahara,
and,
yeah.
and basically what happens is the dust gets blown, because it's dust, and it goes either north or south. Well, I say north or south, it goes both, but we'll glance over that. And basically it depends on how fast it's traveling and where it's going. And basically what happens is you can see it goes in the upper atmosphere, and it travels and then falls down.
And it's carried by often the wind and some in the cloud as well. Now, the water that's evaporated, this now starts to condense, but it's very, very small particles. So small a particle that it's actually carried by the air. It doesn't actually fall down. And you've got these sort of beautiful white fluffy clouds. What do you think these fluffy clouds might be made of, Paul?
Well, the clouds, you see, they're mostly full of this thing called dust, which isn't quite what you think of nice fluffy clouds. They're actually made of lots of, but that's how clouds form. They form around, or water sticks to a dust particle or pollen particle, basically anything, and that's how it basically sticks there. But it's still airborne, which is how, and then basically more water joins, and that's how the white fluffiness goes. And essentially, the more water you collect onto this tiny bit of dust, the more grayer it gets.
Yeah, it gets harder to see through. Yeah. Our little white fluffy clouds are often got a lot of ice in them. Tiny little ice particles, and they're quite high up, some of the clouds. So as you go up a little bit higher, as you know, you see mountains are all covered in this sort of white stuff. Even in, you know, I've seen pictures, never been, I've seen pictures of mountains and they have white stuff on them, even in the summer, even when it's quite hot. And even in Africa, if you go and have a look at the mountains in Africa, some of them actually do have snow on them all year round, because as you go up, it gets colder. So we've got a lot of small particles of ice in these clouds, very, very small, some rain, some water, some sort of sleet, some sort of hail, some sort of snow. They're all in there, all sort of water at different states. And these are then blown by the various different currents, usually towards England.
Well, not necessarily. I mean, we do get our share brunt of it. I'm not disagreeing with that.
Yeah, well, this year it seems all to be coming towards, well, particularly Hemel Hempstead.
Yeah, well, that's just because where we are. You see, that's the only thing to tell. But
Well, my sister lives a bit further north, and she's had some sunny days when we've sort of had rain.
yeah, that's because basically, how big's a cloud? And you say, oh, it's huge from the sky, but it's not too big. You could talk about cloud system being, a kilometre square. The UK is huge in regards to that. So you're not necessarily going to get rain in one part and rain in another, which brings up why we're talking about this on the today. Because, of course, as you know, or if you haven't known, is that currently there are lots of droughts happening. Now, let's name where the droughts are happening, right? Name where's one happening?
A drought, I believe that places like the USA, Canada, where they've been scoring record temperatures, but also they've actually got some of them in northern China as well, and some of Russia.
Yeah. That's more where it's putting it, which is an interesting thing because you don't really assume they're not saying record heat waves, although technically some are. I think North China is also hitting a heat wave.
Yeah, I was reporting this week that quite a lot of northern China is experiencing a heat wave. They've got one of these heat domes that is sort of still present in the USA, although they're hoping that one's going to start subsiding soon.
Yeah, so
but either side of this heat dome, you don't necessarily get the same sort of heat. We're looking at the sort of the jet stream sort of undulating, and where it's going up, we're getting high temperatures, and where it's dipping down, and you're on the sort of the northern side of this jet stream, like we are, then we've had a grotty summer and we've had an awful lot of rain. And in South China, they're having quite a lot of rain.
Mm-hmm.
Like they're having to sort of evacuate villages because of the floods that they're having there. And that's sort of odd to think that they're suffering from a heat dome sort of in northern China, but southern China, they've got, evacuation in place for some of the outlying villages because of the floods, and the rivers are sort of swollen.
Yes, it's one of those tricky things. You have all these heat waves, but around them there are all problems elsewhere because, of course, the water cycle and all these things, they're all related. They're not singular events. They relate to each other. Where there's heat one place, well, it's going to be wet in another.
So let's go back to this idea of the water cycle. We've got the water, it simply evaporates from the ocean, not exclusively, it'll do it from a wet landmass, and this is carried as clouds until it comes over Hemel Hempstead. No, typically land, doesn't have to be land, can be sea, and generally then the clouds will precipitate. They will actually, the water condenses, it's in the clouds, it's moving up and down, and some of that, if it's got a large amount of movement, this can generate quite a lot of friction and static electricity, and that's going to cause extreme thunderstorms, a lot of thunder and lightning, and typically associated with that, a deluge of rain. And that's what we've been having, and what other places are having, this heavy rain falling. And that's going to then basically fill up the rivers,
it's going to fill
the
up
lakes.
rivers, reservoirs, and lakes, and then you've got the problem of overspilling. Basically flooding and floodplains and all sorts of things and problems that way.
And then we've seen some of the landslides that have happened recently.
Yeah, wasn't it Japan?
Yes, Japan had quite a good mudslide.
Yeah, well, it rained, yeah.
And that's just basically the water going into the ground, the water, so much water that it can't be absorbed. That's going to make the soil extremely heavy. And if you've got soil of different types, then in layers on one another, and it goes into one but not well into the other, then it can cause some slippage.
Yeah, exactly. Yeah, that's how what slippage is. The problem is when you've got the two different soil types. It's also rock types as well, I think.
Yeah, it is. And we're looking at the coefficient of friction then becoming quite low. So instead of friction holding the rocks in place, then it doesn't. And so you get a mudslide. And with a lot of water in those things, that's an awful lot of mass to try and stop. And basically you can't. And they slide down a hill and take out anything in their way. And you're looking at a river of fast flowing, basically mud. And that means the water's got an awful lot more mass and kick to it. And we've felt sort of fast flowing sort of water. But if you put in a lot of muck into that water as well, it's got a lot more welly behind it. And that can sort of cause an awful lot more damage.
Yeah, absolutely.
So if the water's falling at a gentle rate, it can percolate through the soil. It can then go into the rocks where basically the water starts to get stored. And in the colder sort of autumn, winter months, you get a lot of water stored there. And we would call those an aquifer, where we store that. And some of the water seeps out there where that rock meets a different type of rock on the outside, and then we get a spring, and coming down from the spring we then get the water flowing into, well, a stream, but in our case round here it flows straight into the River Gade, and our little River Gade is about half full at the moment, which is odd for the summer because often in the summer it's really quite empty. And we've got sort of a fair bit of water in it at the moment, and we can look at the water data there. The water then runs down through these rivers, and in beautiful England, it runs also through the canal system.
Yeah, absolutely.
And surprisingly, the canal system holds an enormous amount of water, and it is used widely in this country by the different water boards to move water from one place to another,
Yeah.
typically where it's wet, to areas
Well,
where it's less wet.
The traditional thing is what they do is they take water from the north and pump it south, because that's mostly that's how the rainfall happens in the UK. Most of it happens in the north.
And typically the west. And so we move it towards the south and sort of the east, which is the way that the canals move, because we've got all the canals taking largely from the sort of 1800s, moving material from the industrial north and Midlands down towards London, really, and the docks where they could be shipped off. And so that water still travels down that way, and it still travels down through the large rivers like the Severn from Wales and the Thames from more of central England.
Yeah, I agree. But now let's bring this all together and go. That's the water cycle. You can see how water moves around the planet.
Well, I haven't quite finished yet.
Oh, I'm
because
sorry.
I've got one important thing that now the bit that is important is that if you've got lots of trees and lots of plants, they then will take up all this water and they stop the soil sort of sliding as much, and they stop the sort of nutrients being pulled out of the soil into the rivers and polluting those. So we get the water taken up by the plants, and then they transpire the water, and amazes me how high water can actually transpire it to be pulled up. Those enormous American redwoods, which are sort of 300 feet high, can still pull a column of water up. And then that water then evaporates through the leaves and, well, almost starts the cycle again, especially if you're in places like the Amazon.
Yeah.
And the Amazon's almost self-perpetuating. And the biggest problem we've got now is by chopping down bits of the Amazon, we've got two problems. First of all, it's not staying as a rainforest. It's starting to become a bit drier. And if they're not careful, they'll manage to produce a desert there. And the other one is, I was reporting today that as they're chopping down the Amazon, parts of the Amazon now are actually liberating more CO2 than they're taking up. And this is sort of a fair bit of the Amazon is now, because it's being deforested and it is sort of degrading because of how much they're thinning it out and what they're doing to it, then we're actually getting, instead of the Amazon being a net carbon sort of reservoir, taking it up, sequestering the carbon, it's now an net exporter.
Yeah, it's not able to do that. So keeping hold of that carbon, it is now, unfortunately, it's why it's called the Earth's lungs, is because that's how it breathes, or essentially breathes, because that's where everything goes in and out. But that's the problem it's receiving.
But it's not just thinking about it as the lungs, it's also doing all this water management. And without doing some sort of trees in the Amazon, they're also going to find later there's going to be severe problems with water maintenance. And this is one of the big problems that we're facing nowadays, that people talk about population exploding. They talk about, are we going to get enough food? But one of the things that's going to be very important is, are we going to have enough water? Big problem.
Yeah, well, it is one of those things where it's not actually what you think. Are we going to have enough water? And the question actually should be, is, are we going to have enough drinkable water?
Yeah, potable water, as we call it.
Yeah, exactly. We're talking ones that are clean for us to drink, as opposed to doing clever things such as, grey water management, which is useful in itself.
Yeah,
But
and for people who don't know what grey water is, it's ordinary clean water, but it hasn't been cleaned and made fit to drink. This is rainwater that you might then use to collect in a barrel and then water your plants. It might be, if you're a bit more efficient, water that you can collect and flush the loo with, because you're certainly not going to want to drink that.
I wouldn't. But
No.
there are people who will, and I'm not mentioning any TV stars or even programs.
Yeah, I think that's probably a good idea. And so we've got probably not enough potable water. And there are certain countries that have got big problems, like countries sort of nearer the equator. And, they're quite hot. But if they've got a sea, then they're lucky, because what they can use is solar energy to basically run a desalination plant, basically heating up the water, condensing it, and removing the salts from that water and making it fit to drink. Now, it's like if you want to go on a ship. If you go on a ship, a little cruise, not that I've ever been, but I am reliably informed that if you want to go on a ship on a cruise, then they don't have enormous sort of stores of water.
No,
Why? Because they can make their own from
Yeah.
the sea.
exactly. They just desalinate it, which is why, if you might seem daft, this is why these ships are so huge. And unfortunately, that's because quite a lot of it is desalination.
Yeah. And so they create a lot of water to, well, not just for the ship to run, because they still have a lot of ships still work on steam turbines,
Yeah.
but they're efficient, and we can get potable water, and then we can use that. And it's going to get to a stage soon where some groups, some places are going to find it particularly difficult to get access to fresh water. We hear all about projects in Africa trying to sort of get sort of water to sort of people, villages, so they can have a sort of a well and move water in so they can do various bits and pieces. And yeah, at the moment we're hearing how we're cutting our aid budget, and people are saying, oh, that's going to stop that. I don't think it really will, because then they're only cutting the budget a little bit. I think there's a lot of political stuff there, but we're moving away from the water cycle. The other thing that I've been looking at is the ice sheet in Africa, in Antarctica, and in the Arctic. They're getting smaller. I've been looking at some data, looking at the sea around Sweden, going right up to the top there. And they're saying, where Sweden and Finland join right at the top. And there, they've got a sea level rise of 5 centimetres. Bit
Right.
further down that sea, then the Baltic, then it's only about 2 centimetres rise. But it's interesting to see how much that's rising. And I've been watching reports on Bangladesh. And Bangladesh is one of those unfortunate countries where a lot of it is sort of barely above sea level. And with just a few centimetre rise, then they're actually losing large amounts of land.
Yeah. They were saying sort of it's now 10%, and it could easily rise to nearly a quarter or even more, which is terrifying, thinking the next 10 years, as opposed to, this long sort of 2050 goals and all sorts of things. They're saying it's happening right here, right now, and it needs to be stopped, which is a critical thing to be. Why it needs to be monitored and have a look at.
Yeah, it's getting that water, isn't it? Because it sounds silly that you're going to be in a coastal village. It's going to be overrun by water, the sea level rising, but that then floods all the drains, and it floods the sort of water supply. So instead of getting fresh potable water, then instead you haven't got water to drink. You've only got sort of polluted seawater, and well, we can't drink that. And so we've got to bring in systems to desalinate or just bring in sort of fresh water. It's a big problem.
Yeah, I absolutely agree with that. That's one of the things, but it's where there are things going with that and how it's working through. Yes, the water's going, it's tending to seawater, and that's having, but that's so that people, what are known as climate refugees, they're maybe having to live away. But it's not the fact that it's more, yes, the sea level's rising, which is a big problem, but they also did decide to live in a place where, I wouldn't say it floods regularly, but was below sea level, or more precisely, you know, below sea level, below river level, really. And that they built lots of things like in the Netherlands, where they've got lots of dikes and um, banks basically to support where they've got. Unfortunately, Bangladesh didn't put those dikes in, which is half the issue.
But if we look at what's going to happen, the problems in even the Netherlands, as the sea level rises, then so they are going to have and experience more problems. And it isn't just because the sea level rises. When the sea level rises, the water table also rises. And so when you want to sort of find it rains, the water level is going to be, the water table is going to be higher. And so the land's going to flood, as we saw in this country in Somerset just a few years ago. We have a large area in the south of England called the Somerset Levels, which are in fact below sea level, and they're far inland. But the water basically built up there from the rain, and it had nowhere else to go, and it doesn't like flowing uphill into the sea.
Yeah, well, that's why they're called that's the Somerset levels. It's a known phenomenon that happens, and then I don't know whose brain's idea was to go and build a house there, but I'm just saying, you know, that's people living there, and then, oh dear, it's flooded. It's one of those things where, am
Yeah.
I sorry that they built on a floodplain?
Well, we're looking round here now where we live, and they're going to build a new housing estate. And what they've done, which is, according to my wife, very sensible, and she's a geographer, town planner, and she said there is a floodplain, and they're not building any houses on the floodplain. What they're doing is they're building the houses on the hill going away from the floodplain. And if you are building houses on floodplains, then why not build them sensibly with a sacrificial ground floor? We saw in Bangladesh on all the TV that a lot of the houses are on stilts.
Yeah, and
But how will they work? I've seen some of those in Somalia, and the problem that they've got there is that your farmers can't farm flooded fields. They come
I
sort of
heard right.
fishermen.
Yeah, I know, and that's the problem. You see, that these farmers are now fishermen, but they're resorting a flood of fish in the market, so they're not able to make any money, and they can't. It's a trouble situation there. There's
Yeah,
not much you can do apart from we go work out, well, how do you turn farmers into workers, or more precisely, how do you get these people jobs so they can earn a living to get better, so they can get out of poverty and all sorts of that sort of stuff. And until that is really worked out, they're going to have to still fish from canoes and things to try to make a living.
it's a problem. So this is the water cycle. We've looked at then the water being evaporated from the ocean. We've looked at the water moving from the ocean to the clouds, being moved around the earth. That's evaporation, condensation, precipitation, and then we've got it percolating through the rocks. We've then got the water then either coming up through the plants, transpiration, or just going back in down the rivers. And with climate change, more of it. So I think we better think about going there, because what I think I can hear now is it's starting to rain here.
Oh, do we have to bring the washing in? I think we do. Whoa.
And this sounds like our typical day in Hemel Hempstead. So I think it's now going to be goodbye from me, Philip, and
Goodbye from you.
oh, thank you.
So I'll get it there.
Bye bye. Take care.
Right, bye.